You have to interface 16K of memory to 8086 microprocessor. You have to interface 16K of memory to 8086 microprocessor, right? Starting from the address 00000H. Okay, what is the chips given? But chips given is 4 chips of 2K and 2 chips of 4K, right? So now you have to write memory tree. That means how you divide this so that you can use the available chips, right? So I have already told you about this memory tree, okay? So and its corresponding memory addresses. See, you're supposed to interface 16K of memory, right? But your memory chips are 4 2KB chips and 2 4KB chips. So memory tree something like this, 8K, 8K, but this 8K memory chips are not available, right? You have to divide the memory until you reach the chips, right? The chip size available. Now, once again divide this into 4K, 4K. You see here 4K chips, 2 chips are available, right? Right, 4K 2 chips are available. That means whatever address range you have here, okay, half that will go for even address, half that will go for odd address. Okay, now can you tell me what is the starting address for this? Every time I'm telling this like an idiot to you. What is the ending address for this? Come on, tell me. 16 KB. 0 0 16K, my dear. Calculate 16K. 03 03FFFH. The total range is 000H to 03FFFH. Okay. Now, if when you divide it into 2 8Ks, what is the range of this and what is the range of this? Tell me. This is very important. This is first standard mathematics, first standard logic. If it is not going into your brain, then you have to take something else, right? Learn this. Okay, what is the address of this 8K chip and this 8K chip? It is 00000H2 01FFFH. Can you tell me 3 F, sir? Okay, yeah, this is H. Okay, can you tell me what is the range of this? Last time I'm going to tell this to you, okay? Next time you should tell me the answer, okay? Okay, come on, tell me what is the address range of this 8K? Next to this, next one, continuous from here. Okay, 02000H to 03FFFH. Have you understood now? Should I use this first standard way of teaching? Is there anybody who did not understand this till now? Okay. Now you see this 8K, once again, because 8K chips are not available. If 8K 2 chips are available, this address range can, even address of this will come to this 8K, odd address of this will come to this 8K. But 8K chips are not available. But 4K chips are available. Right? 2 4K chips are available. You can divide this 8K into 2 4K. Right? That means out of this 8K, even address will come to this, odd address will come to this. Okay? So that means 4K even addresses will come to here, 4K odd address will come to here. And I have explained you everything why we are dividing this even and odd addressing schemes for 8086 microprocessor. Okay, go through the video. Right? Okay. Now, once again, divide this into, okay, anyway, your 4K is finished, right? 4K, you have only 2 chips, right? That is done. Okay, you need not go for address range of this. Do you need any address range for this? For this 4K and this 4K? Tell me. Do you need any address range for this 4K and 4K? You don't require. Because this is the address range of 8K. Out of this, all even addresses will come into this 4K. All odd addresses of 4K will come to this 4K. So I need not address, right? You can say, that's why even and odd, if you write, it's enough. Right? Now, can you tell me, here, 4K, once again, divide this into 4K, 4K. Right? Okay. Divide into 4K, 4K. Is the 4K chips are available? No, right? But 2K chips are available. Right? Okay. Now, what is the address range of this? This address range is required, right? What is the address range of this? Now you tell me. 0, 0, 0, 0, 0, H2. Tell me what the ending address, 4K. 0? No, 0, 0. Is the address range of this, right? But you can once again divide this into two 2K chips, right? Which is available to you for the design. That means the even addresses of this range will come here. All odd addresses will go here. Right? Now, similarly, what is the range of this? Come on. 0, 1, 0, 0. Is it correct? Plus 1. Yes. What is the ending address of this? What's the ending address? 0, 1, 0, 1, F, 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 H. That means out of this 4K, in this address range, all even address will come here, all odd address will come here. So done. You have 2K 4 chips and 4K 2 chips. Okay? Right? Now, let this be your RAM 1. See here. RAM 1. This will be your RAM 2. Okay? And this will be your RAM 3. Now this will be RAM 1 even. This will be RAM 1 odd. This is RAM 2 even. This is RAM 2 odd. This is RAM 3. Okay? Even. This is RAM 3 odd. This is called as memory tree. Have you understood now? Next, what is the next step? Write a table. I explained it in my previous classes. What is the next table? Next table is going to be address range. This you already done, right? We have done it in this slide only. See, RAM 1 even. See, this is RAM 1. RAM 1 starting address is 00000. Okay? And ending address is 00FF. You have done it, right? Here, can you see here? RAM 1 from 0000 to 00FF. Out of that, RAM 1 even will take only even addresses. RAM 1 odd will take only odd addresses. This, whatever range I have shown you here, we have already done it using tree. This is the first step which is very much required. At least you get around at least 20%, 30% marks. Take some that much marks at least. Right? At least your grades may go up. Something may go up. Learn this. Right? More than that I can't do anything for you. Right? At least learn this. This is very easy. Is it tough? Just for anything? Is it tough? Doing this much, is it tough? Right. Okay. What next? Tell me. Table. Okay. Keep your mobile inside. Other than that. Table. Okay. This table is very important. Right, now, I have already explained you about this table. Watch my videos, okay? Just take at least 40 minutes per day and watch, right? You spend hours of time with your WhatsApp and other things, nonsense things. This is very much required. That's not going to give you any CGPA, right? Okay? After 4 years, instead of sitting like this, now do something, right? CGPA is very important now, right? For anything. If you learn here, then only you will be able to do it, right? See, I'm very not happy to tell this in every class to you, right? I feel myself little embarrassing to tell this to you students, right? You're not high school students or you're not any primary students, right? I have to say you learn. I don't know. I find it very disgusting to tell this every time. Okay, this is the table you have to do, right? Okay, first table is for RAM1. Can you see? First write all address lines. What is this? Tell me. 0, 1, 2, 3. All address lines, right? Starting address for RAM1 is 0. See, 0, 0, 0, 0, 0. You can come to next class. Right? Sorry, I'm sorry. You can come to next class. I said sorry. Okay. Sorry, I have some system in my class. Okay.
I don't
Keep
need
the
it.
decorum of the class, my dear. If you come late, anybody will take you inside? Tell me.
I don't need attendance. I just sit.
Sit. No problem. Right? RAM1, RAM2, RAM3. Okay. RAM1 starting address is this. This is 0, 0, F, F, F. Hope all of you understood this. Yes or no? Right? So this RAM1, once again, in this range, you have RAM1 even and RAM1 odd, right? I already told you this. Right? Okay. Similarly, RAM2, starting address is 0, 1, 0, 0, and you can see 0, 1, F, 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 F. Similarly, RAM3. So within this, you have RAM even and odd. Within this, you have RAM even and odd. This is what the table you have to do. This is the next step. If you do this, next step, you may get some 20% more marks. Right? I'm sure out of 200 some 20 students, we can expect only 1 or 2 students get the complete answer for this. That was my experience. Even after telling so many things like this. So have you understood right the table now? Next step is going to be the table. Right. So this table is very important for you. This table is very important. Why? Because you are going to decide the decoder logic. What are you going to design in memory design? Your decoder logic, address decoder logic, right? That address decoder logic, we need to know which are the inputs going to address decoder logic. Same time, which are the inputs going to the memory chip, right? That's also very important. Okay, what are the things we have to decide from this particular table? Remember this, it's very important for you. Okay, you have to decide which address lines will go directly to the memory chip, and then what else? Come on, tell me. Which are the memory addresses? Memory address lines will go to the input of a decoder logic, right? All those things will be decided from this only. So once you get this table, okay, going forward from this table, you have to a little bit study on this table, right? Now, see here, in this memory, you are having 2 K chips, right? You are having 2 K chips, right? You are having 4 K chips. So can you tell me how many address lines are required? Number of address lines required for this particular memory chip? You require 11 address lines, right? That means the 11 address lines out of A19 to A0 will go directly to the 2K chips. Have you understood this? Okay. So how many address lines are required for this? 12 address lines. That means 12 address lines out of A19 to A0 will go directly to the 4K memory chips. Right? It will go parallelly to every memory chip. Okay. That means this much address lines are reserved for the address lines of the memory chip, right? I don't know how many of you know that every memory chip has address lines to select 2K memory out of that, which will be connected to the main address lines, right? Rise Ahmad, right? Isn't my dear something? Don't know. Have you understood this? Okay. Now, the remaining address lines, actually you have to use for the decoder logic, address decoder logic. So I have already solved 2 problems, right? So you have to find out the unique 2 address lines, okay, which will select your RAM 1, RAM 2, and RAM 3. Can you try to get the unique lines here? Is it possible? This is your RAM 1. This is your RAM 2. This is the RAM 3. Can you get a unique line here? Of course, your address lines till here definitely has to be used for address lines of the memory, and A0 has to be is going to your even and odd separation, right? A0 if you are using for even and odd separation, then which are the 2 lines we can use to select RAM 1, RAM 2 and RAM 3? Tell me which are the 3 things. Which are the 2 address lines? 11 and 12. Can 11 and 12, because you need to use the address also, right? If you use that, okay, you have to use the address lines, right? From where you take for address lines? You need 11 address lines and 12 address lines, which is going as an input, right, to memory. Can you use that? It is, I said it is reserved for that. Okay, then what else you can use in this? Refer to this. Refer to the remaining address lines. 12 and 13, you can see here, 12 and 13, it is 00 for RAM 1, it is 01 for RAM 2, but it is 1011 for RAM 3. See, here it is unique, same, here it is same, here it is not same. But still you can use, by using a combination of this through a gate, I understood this, okay? Now you can see it is 10, it is 11, right? So you can use this. See, in one of the case it is giving 10, another case it is giving 11, right? So use a NAND AND gate, a combination of this, okay, to get the output from the decoder logic. So we can use A12, A13, and maybe something like some 0 or something we can use, because your decoder logic has 3 inputs, right? One of the input you can just ground it, doesn't matter. And all this remaining you can use for chip selection of the decoder logic, yes or no? See, in this entire address from A14 to A19 is 0, 0, 0, 0, 0, 0. Everything is 0, right? So can you use it for the chip select of the decoder logic? That is for G1, G2A, G2B. You can use that, right? So accordingly, you just decide your decoder logic. You can see here, A12, A13, A14, it is used for selection of RAM 1, RAM 2, RAM 3. Okay, right? Now you check. When it is 0, 0, 0, can you tell me which line will go high? Go low? This is active low. 0, 1, right? That is corresponding to RAM 1, right? Yes or no?
But you said you don't need it.
If you want to ground this, there are different type of addressing. What we are using is absolute addressing. In absolute addressing, you can use this, no problem. Okay, if it is asked absolute addressing, use A14. Okay, doesn't matter, it is all 0 for all the 3, RAM 1, RAM 2, RAM 3. So use A12, A13, A14. You have an option to use A17 also here, doesn't matter. Along with this, because all 0, it's all 0. Have you understood now? Okay, now see here, when it is 0, 0, this RAM 1, this will become 0. This can select RAM 1, right? selecting even and odd out of RAM1, you can use A0 and bus enable, which I told you in my previous class, right? Now, similarly, when it is 0, 0, 1, right? When it is 0, this is 0, 1, RAM2 gets selected. Now, this is going to the RAM2 chip selection. Once again, RAM2 has even and odd there, right? And even and odd can be separated by A0 and bus high enable. I told you this in my previous class. Right? Okay. Now see here. Now for this combination, see both the combination it should get low, right? Yes or no? It should get low, yes or no? Right. Now see here. When it is 0, 1, 0, yes or no? Or 0, 1, 1. When it is 0, 1, 1, can you tell me which one will get activated become 0? This will become 0, right? Yes or no? Right. Now, at that time, you get a low signal here. Yes or no? Right? Yes or no? Yes.
Sir, at 0, 1, 1 only O3 will be.
Definitely. See here. What is O2?
AND gate. So
it's an AND gate. For AND gate, if any one of the input is 0, what is the output? 0. Right? Okay. So that means this is you are getting active low here. Now, what is another value in the table? Just look at the table here. For RAM3, you are having this is 1 0 and this is 1 1, right? Both the combination comes, but here not a problem. Here 0 1 0 1, 0 0 0 1, not a problem. But here there are two combinations, right? It will give active low at O2 and also at O3, right? It will give active low at both O2 and O3. So how do you get one signal out of that? Connector and AND gate. Because either one of the 0 means it will give 0 only. That's why you take the combination of these two with an AND gate.
So what you mean one not gate also because you get 0.
Ah.
So after that AND gate.
I did think literally.
It's an active low.
You need 0, right? You are getting 0, right?
It's an active low.
It is active low. Output should be active low. See here, my dear.
Okay.
See, this is when it is 1 0. When it's 1 0, what will the output? Suppose if O2 are connected, right? This is O3. When the input to the decoder is 0 1 0, okay, O2 will be 0, right? When one of the input is 0 0 will come here. Active low you are getting. Now this will be 1. Okay, this will be 0. When 0 1 1, listen, when the input select input is 0 1 1, what will be the output? Which output will go low? O3 will go low. When O3 goes low, O2 is 1, still output is 0, right? In both the cases, I can connect this to RAM3, yes or no? That's what required to select RAM3. Whether it is 0 1 0 and 0 1 1, RAM3 will be selected. Right? Okay? This is the way you have to design. Okay. Now tell me, how do you select even and odd? So this will go to RAM3. This will go to RAM1, RAM2, RAM3. So how do you select even and odd? How do you generate? See, you are supposed to generate two chip select here. This will select only RAM1. Right? But how do you separate even and odd? See, take this, okay? You use two OR gates. I have already told you about this, okay? Now see here, this is the chip select for RAM1 even, This is the chip select for RAM1 odd, right? When even address comes, it should get 0 here. When odd address comes, it should get 0 here because this is connected to that particular chip. So I'm going to connect each output of RAM1 here, and for all even address, I will connect A0 here. For all odd address, I will connect bus I enable here. So whenever even address comes, your A0 will become 0, right? This is anyway 0. For the selection of RAM1, you get 0 here, right? When even address is generated, this will be 1, right? Bus I enable is 1, I told you, right? And this will be 0, output will be 1, right? So this chip will not be selected. So same applies for RAM 2 and RAM 3. That's all, your design is done, right? Then
Sir, should bus I enable password not?
bus I enable bar, it will be 1 when even address is generated. When odd address is generated, how does it going to give 0 here? Because A0 is 1, right? When odd address is generated, this will become 1 and this will become 0. Anyway, this is 0 because of this RAM 1 selection. 0 will come here. This particular chip will be selected. Have you understood this? You have to sit and work. Unless you do that, you cannot understand this. Okay? It's very important. So this is what actually your final diagram is. See here, this is 2K chips. Hope you understood this. Okay. See, A12, A13, A14 is going as a selection input. What about remaining?
Chip selection.
Right? You can give remaining to your chip selection. See here, memory bar, memory slash IO bar is connected. Can you tell me how this is going to get 1? Because for this chip to be selected, G1 has to be 1, this has to be 0, this has to be 0, right? So how do you get 1 here when I connect memory slash IO bar here? Come on, tell me. I want somebody to answer this question.
If it's
Exactly. When microprocessor does memory read and write, in this particular pin, it is going to put 1. So anyway, it requires 1. Now can you tell me, this is 0, right? A16, A15, 0, both 0 getting 0. What is another option for this? If I don't want to use memory slash IO bar? You use any other, you use an OR gate, right? It's NOR gate. See, instead of memory slash, see why memory slash IO bar is used? Because all the address lines are used here, right? You don't have any other address lines. Another option is you give only two A17 and 18 here. A19, what you do? Connect a inverter and give it to this. You can do that. Yes or no? No one has answered me this question. Right? My question is, if I don't have to use memory slash IO bar, what's the other option to make this one for me to this address? Definitely, see, instead of using A17, A18, A19, 3 inputs to this, use only 2 inputs. Right? So A19, it is 0, right? But you need 1. What do? You connect one NOT gate and give it here. Done. It will be permanently selected.
Why can't you just use
VCC. You can use, no problem. But absolute addressing mode. Remember, absolute addressing mode means as much as possible you have to connect address lines and control signals as a input to the decoder logic and the selection inputs. Incremental addressing, no problem. You permanently make this VCC, permanently make this ground. Okay, this one permanently make this ground, no problem. Absolute no problem. Yeah.
What needs 12 address lines are missing?
Which one? 4K, right?
So it needs 12 address lines.
Of course. Another address lines will go directly to that. Don't worry. It will A1 to A12 will go there. Okay.
So we have to draw it like this with the path.
See, I'll tell you one thing. It depends on the timings. If you do this, okay, if you do this, you get 80% of the marks, total marks, 80 to 85%, right? But this will give you, it's the same thing. This part is same thing, right? Only you're drawing 2K, 4K memory. you are trying to separate your even memory bank and odd memory bank. Yes or no? Sorry, this is odd memory bank. This is even memory bank. Tell me why I said this odd memory bank. Anybody give me the answer? Because BH is connected. Everything is connected to BH here. Why this is even memory? Because A0 is connected. That's why this is even memory. This is odd memory bank. This is even memory bank. Right? Whenever you are trying to read 16-bit of data, all entire 16-bit of data is read. You see here, you are connecting D for all odd, you are connecting D15 to D8. This is very important. When you draw this diagram, don't write D0 to D19. No, your all odd address is holding higher bytes. I told you about this in my previous class. That's why it is actually going in the higher order data bus. Your all even address is holding lower byte of the data, right? That's why you are having lower order data bus here. That's why all even bank you connect D0 to D7, all odd bank you connect D8 to. Can somebody tell me why can't I connect D0 to D615 here? It asks somebody. I want the intelligent answer from this. No, I want somebody else. Why can't I connect D0 to D15 here? Dharma, tell me. My favorite student. Dharma, tell me. Huh? Address lines. Address lines are already given. No? For this memory chip, why can't I connect D0 to D15? Another favorite student. Tell me. Before I get fainted, please somebody give me the answer, my dear. No. This side. This side, somebody. Yourself. I want a small answer, my dear students. Why can't I connect D0 to D15 here? My question is, why can't I connect D0 to D15 here? Why I am separating higher order bytes here, lower order bytes here? Can somebody tell me answer? Guys? Huh? Come on. How many know the answer? Lift your hand. What about others? You're not confident? Huh? Tell me. Sing.
So it is 8-bit memory.
Exactly. Why you are doubting? Each memory chips are only 8-bit, right? How can you give 16-bit in that? I just wanted to check your level of understanding. Right? It is only 8-bit memory. It's only 8-bit memory. That's why I'm just taking higher order bytes here, lower order bytes here. So at a time, microprocessor takes the data, 16-bit data. That's why this even and all addressing schemes came here. I've understood this. Okay? Okay, fine. Now let us go for 80286. Can you tell me how many address lines are there for 80286? 80286 has 24 address lines, yes or no? See, if you know how to get a memory tree for 8086, 80286 is just extension of one more zero. That's all. That's all. 80286 has how many address lines? It has 24 address lines. That means how much memory it can interface? 2 to the power of 24. How much 2 to the power of 24? Use my calculators. Now use mobile calculators. Now you use it at least. 16 MB. Right. So how many address lines are there? Can you tell me what is the address range? If suppose my starting address is 000, can it is correct? One more zero. What is the ending address? Yaf. Is the starting address and ending address of 16 mega locations of entries. Now suppose if I give an example to you, can you write the memory table for this? Come on. Come on. You have to interface 4K ROM to 80286, starting from the address 08000H, but chips available is only 2716. Can you tell me size of this chip? What is the size of this chip? I have told you in my previous class. I told you. Remember this. अभी थप्पड़ मार के सिखाऊंगा मैं सब. हाँ. Tell me. Huh?
16 by 8.
Exactly. Rise. Very good boy. Divided by 8 is 2K. What is 27 represents? Wrong. I told you about this. So chip available is only 2K chips. Right? Now just do the tree. Required is 4K. Now 2K. 2K. What is the address range of this? Tell me. Starting address is 0800000H. Can you tell me what is the ending address? Can you write the? Do I need the address for this? Do I need the starting and ending address for this? This is even of this range. This is odd of this range. That's all. Have you understood this? What is the ending address? 080. Yep. It's very easy. I don't know why you are not. Hope all of you got your marks, right? Right? Mucho, right? Marks. But I'm telling you, at least have some marks, get a good CGP. Right? Okay, we are here to help you in all aspects, and you are not coming. That's the problem. Right? Okay, fine. What is the address range? What is the tree address range? See, this is ROM1, given is this one, ROM1. What is the next step? Come on. After this, what are you supposed to do? Cable. Go, put the table, make the table. See, you have only one ROM here. Right? Okay, now tell me.
You can use 11 and 12.
What are the values you can use?
11
Of course, it's a very simple design. Can you do this? Simple design. So how many address lines will go to the directly to the memory chip? 11 will go to memory chip. Assume that this from A1 to A11 will go to the memory chip. Okay? Fine. Okay. Now what else? Just think about this. Just answer the numbers. Isham.
Yes, sir.
Aditya. This fellow is Connie. Prakriti Garg. Deepti. Larissa. Wait. Okay? Just wait for some time. Deepti.
Yes, sir.
Arisa.
Yes, sir.
Marvin. Hitesh. Zubair. Mubashir. Naganandan. Johan Girish.
Yes, sir.
Sinan. Mohammed Sinan. Dhairya. Vivek.
Yes, sir.
Alex.
Yes, sir.
Nimish.
Yes, sir.
Aryan Ramabhadran. Dharma.
Yes, sir.
Suraj. Saini Suraj. Kailash. Absent. Naina Sitlani. Said Abdullah. Paridhi. Jaskaran Singh.
Yes, sir.
Srila Murthy. Malavika. Aryan. Tanish. Vishnu. Rajdeep. Rashikesh.
Yes, sir.
Ameya. Hadir Shafi Mohammed.
Yes, sir.
Prathamesh.
Yes, sir.
Venkat.
Sir.
Suleiman.
Sir.
Prakhar Singh. Ajit. Janvi. Absent. Ishan Kurian.
Yes, sir.
Varshita. Mustafa. Mohammed Shifa. Munip,
Yes.
Uday Shankar Muthureddy, with Sai Shri, Lynn, Bhumi, Anand Bhumi, Yashita, Rais Ahmad,
Yes, sir.
Rushil, Sarashwan, Par, Hatik,
Yes, sir.
Pratik, Nupur, all absent, I don't know. Nikita, Sofana, Zaid Mohammed, Saransh Shukla, Harshit, Radhika, do this problem. Olvika, Ashwin, Snehasini, Sania, Said Abdul Nihal. Okay, so complete this 8, 12, 8, 13, 14 again. Very easy. Attendance already हमें इंस्ट्रक्शंस है